For this Edpuzzle, I want to review some concepts from the Alchemy unit and also get a clearer understanding of exactly what you do and don't recall and are able to use from the Alchemy unit. I'm titling this chemistry content so far. It is not all of the chemistry content. It is the information that is important for us to take forward into the smells unit. In Alchemy, the focus of the unit was learning both the language of chemistry and the structure of the atom. Knowing the structure of the atom allowed us to acquire the knowledge that it is impossible to turn one element into another in an ordinary lab setting. So I was unable to turn copper into gold because of the structure of the atom. The atom is composed of three parts, which are protons, neutrons, and electrons. The protons, so protons are found in the nucleus. They have a charge of +1, and they have a mass of 1 atomic mass unit. All right, what do you know about neutrons? Neutrons are found in the nucleus. They have a 0 net charge, and they have a mass of 1 atomic mass unit. And then what about electrons? So electrons are not found in the nucleus. They have a net charge of -1, and they have mass of 0 atomic mass units. If we're going to summarize the parts of the atom, we will look at charge and mass, and we have all three possibilities, and these, oh, I should also put in location. Proton, neutron, and electron. Protons, nucleus. Neutrons, nucleus. Electrons, outside the nucleus. The charge is +1, neutron is 0. Remember, neutron is neutral, and electron is -1. You can think of proton plus, neutron neutral, so the letters alliterate or align. Mass of a proton is 1, mass of a neutron is 1, mass of an electron is 0. Electrons move really fast. That might be one way that you can think that the mass is 0. They can't move really fast unless they're extremely light particles. That might help, maybe not. So this is what we have. The electrons are on the outside, neutrons and protons are in the middle. And remember, we can summarize this in our chemical symbol. Lower left is the atomic number, proton number. Upper left is the mass number, total number of neutrons and protons. The question, which part of the atom always defines the identity? And it is the number of protons. So this number and this symbol always go together, and they always match what is on the periodic table. So these two go together, always match what is on the periodic table. One of the things that we talked about in alchemy was stability. We talked about the stability of the nucleus, and we also talked about the stability just in general of the atom. Chemistry is concerned with the chemical behavior of atoms, and one of the behaviors we look at is reactivity. Reactivity can be defined as how likely a particular atom is to interact and change another atom, such as in forming or breaking bonds. Reactivity is totally based on the electrons. So far, we've seen one behavior of reactivity, which is ionic bonding. Ionic bonding is when one or more atom loses electrons to form cations. The lost electrons go to another atom to form anions. Remember, cation, the T is a plus, it lost negative charges, so it becomes positive. And anions, remember our acronym is a negative ion. It gained negative particles, and so that is why it is negatively charged. The goal of gaining and losing electrons is for the electrons in each atom to stabilize their outermost or valence shell of electrons. So that's one way to think about it, is how do we make the valence or outermost shell the most stable configuration, and that is what we call full or completely empty. Alternatively, we can think of each ion, not atom, having a stable total number of electrons, and this stable total number of electrons is the same number of electrons as the noble gases. So when I look at the total number of electrons in a stable ion, they typically have 0, 2, 10, 18, I don't have this memorized, 36 electrons, same as the rightmost column on the periodic table. I want to review the process of forming ions. We'll do our example of sodium. It has 11 protons and 11 electrons. When I see how they are arranged, the outermost shell only has 1 electron, which is not stable. So 10 on the core, 1 on the very outside. If I look at fluorine, it has 9 protons and 9 electrons. If I count the outermost shell, 1, 2, 3, 4, 5, 6, 7, that is not stable. Also, 9 electrons is not stable. 10 electrons is stable. It wants to gain 1 in order to get to 10. Where does it get it? It gets it from the sodium. So the sodium totally gives up its electron to the fluorine. So on the outer shell, we now have 1, 2, 3, 4, 5, 6, 7, 8 electrons on the outer shell, or a total of 10 electrons. And notice this is the ion. And the fluorine also has 10 electrons, 2 in the inner, 8 here, so total of 10 electrons. Because it's gained 1, 10 electrons, 9 protons, it has a negative charge. Sodium, 11 protons, 10 electrons, it has a +1 charge. So 11 positive, 10 negative is +1. I now have an ion that has a positive charge and an ion that has a negative charge. Because of electrostatic interactions, they stick together. It's a very strong interaction and form a solid sodium fluoride. So process, first I lose and gain electrons to form a charged particle. And then the ionic bond is just that electrostatic attraction between the two charged particles. Another example would be magnesium. Magnesium is element number 12. So I've got 12 protons. When I'm an atom, I have 12 electrons. I've got 2 in the outermost shell. So I count the outermost shell. I've got 2. 2 is only stable for the 1s level. It wants to lose both of them. So I go from 12 electrons, which is not stable, to 10 electrons, which is stable. But in doing so, when I lose 2 negatively charged particles, I become positively charged. So where do those electrons go? 1 goes to chlorine. Chlorine is element number 17, so I had 17 protons. I initially had 17 electrons. I gain 1 to go to 18 electrons, which is stable. And this, because I've gained 1 electron, I am now a -1 charge. Same thing happens to the other one. I have Mg2+. I need 2 negative particles in order to come to a 0 net charge. So therefore, I need 1 magnesium, 2 chlorines, so that I will have a +2 and then a -1, -1. That will then give me a neutral compound. Again, the 3 ions stick together because of electrostatic attraction, positive attracted to negative. What does that mean for the Smells unit? In the alchemy unit, we learned about ionic bonds. 1 atom gives up electrons to form a cation. 1 atom takes electrons to form an anion. Then the ions stick together because of electrostatic attraction, and the number of atoms that stick together has to give the compound a net total charge of 0. In the Smells unit, we're going to learn about covalent bonds. This is where electrons are shared between 1 or more atoms. We do not form ions. The sharing of electrons is what makes the atoms stick together. So that is what the bond is going to be, is sharing of electrons. In ionic, it was electrostatic attraction. For covalent, they're actually sharing the electrons.